The first question says simplify 6x to the power of 1 over 2 whole power 3 divided by 2x. So let's first solve the numerator. Whenever you have a power outside the bracket and inside the bracket, both the powers get multiplied. And always remember to distribute the power on the coefficient as well. So it's going to be 6 to the power of 3 times x to the power of 1 over 2 times 3. As you can see, the power of 3 was distributed to both the terms. 2x comes down as it is. 6 to the power of 3 is going to be 216 times x to the power of 3 by 2 over 2x. Now, 216 divided by 2 is 108. And for the x, as we done previously, whenever we have similar bases being divided, we subtract the powers. So x on its own has a power of 1. So 3 by 2 minus 1 is going to be 108 times x to the power of 1 over 2. Because 3 by 2 minus 1 is half. And that is your answer. Work out one whole number 11 over 25 whole power negative 1 over 2. So whenever we have negative powers, first step is to make them positive. And that can be done by flipping the fraction or like whatever the term is. So in this case, before we flip the fraction, we need to convert this into an improper fraction from a mixed number. So to convert a mixed number into an improper fraction, we first multiply the denominator with the whole number and add the result to the numerator. So 1 times 25 is 25. 25 plus 11 is 36. So 36 over 25 whole power negative 1 over 2. Now we can flip this. So that's going to be 25 over 36 whole power 1 over 2. As you can see, when you flipped it, the negative sign became positive. So now we're taking the square root of both 25 and 36, and that's going to be 5 over 6. That is your answer. Now we have a quadratic inequality that we have to solve to find the values of x. So we begin with multiplying the coefficient of x squared with the constant. So that's 2 times 3, which is equal to 6. Next step is to find the factors of 6. Other than 2 times 3, we have 6 times 1. Now what we have to do is we have to replace the middle term, which is 5x, with a set of factors from these factors that we've written. We have to pick that factors which when added or subtracted give us the middle term, which is 5x. So we know 2 plus 3 is 5. And we know 6 minus 1 is also 5. Both the options seem correct right now. Let's try with the first option and see if we get the correct answer. So if we replace 5x with negative 3x minus 2x over here, and if we factor by group after that, first two terms are one group and the last two terms are another group. Between the first two terms, we have x common. So in the bracket, we'll have 2x minus 3. Between the last two terms, we have negative 1 common. So that's going to be 2x minus 3 as well. As you can see, we have 2x minus 3 in both the brackets, so we can take them common. And the next bracket, we'll have x minus 1. Which shows that we don't need to use 6 minus 1 over here because 2 and 3 give us the correct answer. So we have an inequality in this case. It's not an equal to. So whenever we have a quadratic inequality, once you have like factorized it, I suggest making a rough graph. One value over here is x equals to 1 and the other is x equals to 3 by 2. So let's put the 1 over here and 3 by 2 over here and make this rough quadratic graph. So at x, whenever your initial inequality is less than 0, that means we look at the value underneath the x-axis. Why? Because basically, this equation represents y. So y is less than 0. Y is less than 0 over here, underneath the x-axis, not above it. which means our focus is going to be on this part of the graph. Now, if you notice at x equals to 1, your values of x are increasing. And at x equals to 3 by 2, your values are decreasing, which means x is going to be greater than 1 and x is going to be less than 3 by 2. Once again, our initial inequality was 2x squared minus 5x plus 3 less than 0, which means we are focused on the region where y is less than 0. Y is less than 0 beneath the x-axis. Beneath the x-axis, if you look at the behavior of the values of x that are our solution over here, at x equals to 1, x is showing an increasing trend. Whereas at x equals to 3 by 2, it's showing a decreasing trend because we're going towards the left-hand side, which means at x equals to 1, it's x greater than 1, and at x equals to 3 by 2, it's x less than 3 by 2. The next question says that the histogram shows the speeds in miles per hour of cars on a road. 14 cars were traveling over 50 miles per hour. Calculate an estimate of the number of cars that are traveling between 42 and 49. So let's first mark 42 and 49. This is 42 and this is 49. So since it says an estimate, so the approach that we're going to use over here is, we know that 14 cars were traveling over 50 miles per hour. So that's basically this portion. So if we count the number of boxes from 55 to 65, we can see that the total boxes are 50 over here. For over here, over 50 to 55, that's basically 125. Because we have 50, because we have 25 boxes, because we have 25 small boxes in one big box. So we have 1, 2, 3, 4, 5. So if we do 25 times 5, that's 125. So now we know 14 cars are basically represented by a total of 125 plus 50 boxes, which is basically equal to 175 small boxes. That's what I'm going to write over here. So 14 cars equal to 175 small boxes. So to find how many cars are represented by one small box, I will divide 14 by 175. Find the value of one small box. And this is the cars. So if we do 14 divided by 175, that's equal to 0.08 cars. So 0.08 cars equal to one small box. Now let's count the boxes for 42 to 49. Over here, if we look at the 42 to 45 part, just one big box. 3 boxes horizontally and 5 boxes vertically, which means each big box will equal to 15. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So 15 times 9, and that's going to give us 135 small boxes for this portion. Let me just use a different color for that. These are the small boxes for this portion. Now, for this, from 45 to 49, we have 4 boxes horizontally and 5 vertically. So that's going to be 4 times 5. And total number of big boxes are 1, 2, 3, 4, 5, 6, 7. So times 7. So 4 times 5 times 7 is going to be 140 small boxes. So total boxes are 135 plus 140, which is 275. Now we have to find the cars for 275 boxes. So for that, we're going to multiply 275 with 0.08, because 0.08 cars represent one small box. So the value for 275 small boxes is going to be 275 times 0.08, which is equal to 22 cars. So that's your estimate of cars which are traveling between 42 and 49 miles per hour.